Good afternoon, everybody. So, welcome to today's session. Just wanted to get a confirmation, like always, whether you can hear me loud and clear. Let me get the questions window outside so that I can listen to it. Hi, Srilal. Good afternoon to you. Good afternoon, Gaurav. Hi, Pani. Hi, Sandeep. Wonderful. Vikas, can you hear me loud and clear? Okay, great. So, it's a usual trend that I have seen is initially you'll have a core set of people fine, but as it goes on, when it reaches the end, I've got no idea why it reduces down, So we had a very good batch. I don't remember the strength of this batch, but then as we go ahead, we are there on the second last day and we only have got 5 people. That's sad. Right, guys? Sandeep is saying 8 beats is a little bit hard, but then look at the positives. Everything is not dumped continuously, right? So some people see that, okay, now let's hear the recording. I know whether I'm staying live or I can. Once the recording options is given, people tend to follow that. Hi, Vikas. Yeah. Okay, good. So guys, let's get started rocking. So let me start with my slide deck. And of course you would know the admin part of it. And let's get down to the week-wise session so that you know where we are. Hope you can see this loud and clear. Is the screen a little bit smudged or something? No, right? It's fantastic, and my voice is also like always clear, right? Cool. Okay. Fantastic. So what we have done is we have finished with HDFS. We saw created a cluster. We saw MapReduce. We saw Pig earlier. After that, last week we saw some examples of Hive. Just wanted to check, were you able to finish off with all the examples of Hive till now? Where are we with regards to that? I hope you have finished all the exercises. Can you let me know, guys, who were able to try it out? Okay, Pani was lacking a little bit of a time. No worries. Okay. Gaurav, no excuses for you, young man. Okay, not all the statements, but then you did try something. Okay, fair enough. Because when we reach a, hey, that is not needed, what you just said right now. That's not needed. So that's fine. So just pulling in like no excuses. So yeah, if you have finished, Vikas, wonderful. So today we are going to start with HBase, okay, which is going to be a completely different beast. Okay, so what I'm going to do is I'm going to start with HBase, because if I finish up the whole of HBase, you wouldn't have time to look at it, because it is almost like another mini Hadoop. In fact, I have Pani, for Hive, I have got all the hey, for Hive and for HBase, that the documents were sent to you in the last lot itself. I'll just show you what I had told to send to them. So let me get down to in the week 5 itself. Okay, see, these are the documents that I have shared it with you, the pig, the scope, all the data sets and all of these things. Hive, did we not do some examples? I showed some examples, right? Or I did not show the examples. Hi, Pankaj. I thought I have finished Hive, okay, it was just theory. Okay, sorry about that. Pani, no worries. Send me the link and I can send these files to you straight away. Okay, no worries on it. Anybody who haven't got these links, no, Pankaj, this document was sent to you last time itself. Okay. Sorry, really, my apologies, guys. Pankaj says he got the Hive doc. Okay. What about the data sets, that is customers, transactions? These are the two data sets that I have used more. Okay, when you did the pig exercise, what I told the Edureka folks was, when we did the pig, you wanted to have a look at that, right? So along with that, I told them to send this whole set of files. Okay. My apologies. In fact, there was a total lack of communication, so I thought it would have happened. And since last time I had to run off, so that was the case. So maybe I didn't check it up properly. Okay, no worries. I'll ensure that you will have all of these documents, which covers up. I'll show you the Hive docx. Okay. Sorry, Gaurav. Okay, so now you've got a valid reason not to do it, Gaurav. Okay, that's wonderful. So I have opened up the Word document, and let me see here. This tells you what you have to do with Hive. Okay, we are going to create a database. Okay, I think I did a demo on the transaction record. You can load it from NPath, find out the number of rows, columns, all of those things. You can create a partition table. Okay, do you want me to go ahead and do that demo for you so that we can walk through these things, guys? Or you can do this Hive things and come back to me over the weekend. See, this is what I'm planning, since almost all of you are there. Yeah, I think that's what, I think we should not waste our time in me doing those examples. You should do this thing and come back. No worries, Vikas. I will discuss on the bucket part of it. So let me see how many participants do we have. That's good. We have got 9 now. So a few people have said it was only 5 some time back. We have got Vivek also with us now. So that's wonderful. And we have got Pankaj also said hi to me. So that's good. So that's nice. So and again, guys, after talking to Edureka team, what they said is that instead of taking an additional hour today, okay, we will have it as per the normal timings, only 3 hours. We will extend it by 1 more week. I think that would be better, instead of stretching it out today and on next Sunday. Okay, we are going to have it on the last, we are going to stretch it by 1 more week, and in the last week we are going to develop some projects for you. Okay, so hopefully this week the project details should be there with you, so that you have got 2 weeks of session wherein you will take up some live Twitter feed. Okay, I have also suggested some examples which the teams are working on right now, more to do with the real life analysis, what's happening, so that you would be working on those projects and you will, as a group, and you will be showing us the working also. Okay, how did you work with the project? So it's a kind of a collaborative effort. Folks would come to know each other a little bit more, because interaction needs to happen. So that's what our plan is. So we are going to stick to the same format. It's going to be there from 2:30 to 5:30. Okay, so based on that, what I have done is, I was supposed to go by, as some of you might know, I'm again back to Hyderabad tomorrow. So instead of taking tomorrow's morning flight, I'm taking the same 8 o'clock evening flight today. So we have got comfortably time. No worries, guys. 3 hours we can do very good job. Okay, cover this up, whatever is planned for today, and do it next Saturday, and next Sunday, not Saturday, next Sunday, and the Sunday after that we will wrap it up. Hope that would be clear, everybody. Vivek, can you hear me, friend? Because you haven't said hi to me till now. Just kidding, Vivek. Okay, so yeah, there he comes with his hi. So like I said, Vivek, next week also I am there in the same place, Microsoft. So that was an amazing session. I had taught or mentored or brainstormed with 60 folks, you know. First 3 days it was developers, 20 each. On Thursday it was project managers, 20 folks, and on the last day it was development testers, 20 folks. So 60 people, a lot of things happening on the big data world from the Microsoft front also. So just wanted to share that. As a use case, what are they doing is, use case is important. They have got about 120 OLTPs, okay, and all of them are in silos. Some of the data might be duplicated, might not be duplicated. So they wanted a kind of a data exchange where all the data has to be there in one place and people can do cross OLTP kind of reporting. So that's something that was discussed with them earlier. So just to summarize, that's a good use case that is coming up nowadays. I had spoken to even JP and some of the other companies are also planning to do that. Get OLTP stuff, and instead of using one data warehouse, put everything, dump into Hadoop, and then look out for an analysis. Okay, so just to get things very clear, I'm going to send this document, okay, all of these things. Okay, and in front of you itself, I'm going to do that right away. I'm going to write an email to Hisham, and I'm going to say that please send this across to today's batch so that you should get it. If you don't get it by tomorrow, ping me back again, guys. Okay? And thanks for the understanding last week. I really appreciate that. Was not in a mental frame to cover, but then I thought that let me do at least 1 hour. So let me write to Hisham, and let me write to Kapil also. And let me write to Vineet also. I'm sure they will do this. Docs to be sent to Sunday 2 p.m. batch. Dear Hisham, please send the docs. Please send all the docs which I had uploaded in the Google Drive, okay, drive to this batch. They were okay. I was under the assumption that after the pig lecture, this would be sent to them. Okay, this would be sent to them, but that was not the case. Okay, folks were not able to practice on Hive since they did not have these documents. Can you please send it to them ASAP? Right now would be wonderful. Would be wonderful. I'll give a smiley to him, and that's fine. I will just take a screenshot of the current thing so that he knows what am I referring to. I don't want any more lack of communication. Okay, I'm just going to take the screenshot so that he knows what am I referring. Okay, there we go. I have taken up the screenshot. I'm going to attach this with this email. Okay, and I'm going to say send. Lovely. So that finishes that aspect of it. Sorry about that, guys. So that's good. Let me take the questions out once again. It got back to the same thing. Okay. So guys, let's continue. Because you had a question on partition, so let me go back to the Word document. Give me a second. Like I said, buckets. Yep. You had a question on buckets, so let me bring that aspect to you. I should have the Word document. Let me get back. Buckets is a kind of sub-partitioning, okay? Why do I do partition? So that I can put it into different, I can break it up into different columns. So let me go back to the create table. See over here, folks. So what are we doing over here in the create table? Create table transaction records by category. I'm giving a structure to the data that I have in the TXNS file. Partition by category, that is string. So I'm going to partition it into different categories. So there will be separate HDFS files will be created based on this particular category. Then if you would want to do any bucketing, you have to have clustered by. So I'm clustering it by state into 10 buckets. Okay, that's it. So I need to set these things, okay, so that Hive can understand partitions and bucketing. And then I load the data into the transaction. From transaction records, I'm writing into transaction category. So you see that it is based on the partition, okay. So now when I do a ls, So see over here what command am I doing. I'm looking at the warehouse, and in retail.db inside transaction.category, see over here the different files that got created based on the category. Okay, so this is how it got. You could get into each one of these things and look at it also. Just a second, just wanted to have a quick small glass of water. Just one sec. I'm back. So you could see this. Then, since I have said earlier as to 10 buckets, when you go inside each of the partition, see over here, I've just taken it as one category right now. Okay, dancing, category dancing. You see there are separate files that gets created. Okay, so for buckets. So bucketing is just a concept of a kind of a sampling. Based on something, you can break up the categories into subcategories for bucketing purpose. This is basically for sampling, nothing other than sampling purpose, friend. Okay, so that's what is the concept of buckling. Okay, so Vikas wanted to have a quick look at the create table syntax. So let me go back. There you go. Hey, Pani says there's some background noise. Yeah, that also, I thought so when I logged in. I thought that it might have been something. Let me just remove this. Hey, that noise has gone, right, Pani? No, it is still there. Okay, so for me, I think the voice, I've got no clue, because what was happening is yesterday I tinkered with my the bars BAZZ of my system. So let me go back and show you what I did. I went to hardware and sound. I went to Realtek HD Auto Manager because it was too low, you know. So I went to sound effects and I checked and unchecked this loudness equalization. Okay. Now, is there any difference, Pani, when I check it? Because in the morning batch, it was giving me some music, so when I unchecked it, it went away. It is still there, right? Okay, so this has to be something. Oops. Yeah, there's a lot of noise I could see also. Is it really disturbing? Okay, sorry about that, Pani. Okay, so I got no, yeah, now it's gone. See, for me, I was hearing a lot of noise, so when I removed this loudness equalization, that noise went away. Sorry about that, Pani, my apologies. Okay, only once I hear the recording, I'll come to know what was the noise that was coming in. So coming back to your question, Vikas. Okay, there it is. Yes, category is only available in the partitioning script, but for buckets, clusters, you can have more of one of the two columns. Exactly. See, why am I partitioning? I should partition based on a column, right? So that's what is the partitioning concept. I'm partitioning it based on the columns, but for clusters, but for buckets, which is more like clusters, I could use any of the other columns also within that partition. Make sense, Vikas? Okay, wonderful. So that's, you're welcome, Vikas. And I replied back to your other email also. Okay, so last week I was at leisure on Thursday and of course Friday, a lot of time at the airport also. So I replied back to all my pending emails also. So you would have got my reply on everything. So this document will come down to you. Let's please practice this. Okay. Similarly, there will be something that will be coming down on the edge-based stuff also. Wonderful. So let's get started with our original agenda for today. I think the document would have gone by now. I'll just close my this window, my Outlook, and let me come back. Okay, that's something that is pending, Vikas. Okay. You wanted the combiner and the partitioning MR example. I have that. Okay, so if you don't mind, if I'm not asking too much, just send me a quick reminder email on the same thing, and via reply, I'll reply back to that. So this is for everybody. I will tell them to send across the partitioning code also, the MR code also to the current batch. So everybody will get that. I have got a code which talks about the combiner. How does combiner help you? And if you want to create a partitioner, how do you create a partitioner? So it was for that. So after that, I think all the questions of the whole team is answered. Wonderful, guys. So let's get back to the slide deck. And let me put this into the slideshow. So like I said, what we have done till now is we have finished with our HDFS components. We saw the MapReduce components. We saw the working of Pig. Hive, I had given you a demo, but then there's a full document that you can actually try. Okay, and you could try and if there's any questions during the week, send across an email to support and to me, and we will be there to help you. So today we are going to start with, sorry, page up. Today we are going to start with HBase. Okay, we will see what is HBase, why do I need HBase, and the history that I'm going to show you has been taken up from HBase in Action Book. Okay, I'm a good friend of Amandeep Khurana, the guy who was one of the lead committers who started with this HBase. So we had bumped into each other in about 2008 when he was doing his masters in California. So that's the time when we got a chance to meet up. So at that time he was just starting to use HBase and C. He was working for Amazon at that time. So that's how this is a little bit close to me, because a fantastic concept, okay, a kind of a database that we have within the Hadoop ecosystem. So a couple of the stuff is taken from that slide, but then I have created additional material around it. Okay, so that's about HBase. So we are going to break this HBase into two parts. One part, I'm going to show you the CLI. That is what is going to be there in the slides and what you'll be trying it out. There is a Java code part of it also that we will be seeing it next week. Okay. Today, if time permits, we will, after the CLI part of it, we will go ahead with Scoop. Okay, that was supposed to be done the next week, so we will try to start with Scoop. Scoop is basically for moving data between relational data stores and HDFS. There are some exercises for that, like you saw scoop.docx is also one of the document. So that's what we will do today. We'll see how time goes about. So once we finish it with today, and next week we will again do HBase and we will do Zookeeper. Okay, and then last week is, like I said, we will be working on the project part of it. So that's the next 2 weeks for you folks. So let's continue. What is HBase? HBase is basically a open source, distributed, sorted map data store that was built after Google's Bigtable. So we have got, again, the reason why HBase came about is because Google shared via a white paper called as Bigtable how they are using a kind of a database which is NoSQL. Okay, so when we say NoSQL, it is not only SQL. Okay, that's what is the NoSQL domain. There are various variations of NoSQL. You have got columnar database, you have got graph database. Okay, you have got in-memory database. So a lot of different variations are there. Okay, we'll see some of these things as we go ahead in the session. So from the GFS came HDFS. From the MapReduce came the MapReduce programming model, and from Bigtable came the HBase component. Okay, Mike Carafella was the gentleman in 2007 who started with this concept of HBase. He originally started with this HBase concept. Okay, so that's the background. We have got somebody else also who has joined in right now. Hi Kaushik, I hope you can hear me loud and clear. Wonderful. Thank you. So let's move on. So that's about the HBase part of it. So let's look at what is HBase. First, HBase is a database. Okay, it is Hadoop's database. It is often described as a sparse because it's spread over, distributed, persistent, multi-dimensional sorted map. which is indexed first by a row key, then by a column key, and then there are 3 versions of the timestamp over there. Okay? Yeah, you're welcome, Kaushik. So that's what is an HBase. It's a database. It's something that is on top of Hadoop. So when we say Hadoop, what is the access pattern what we have for Hadoop? It is write once, read multiple times. Okay? Worm. Write once, read multiple. WORM is what is the access pattern for Hadoop. Whereas in HBase, it is frequent random updates and random retrievals. So if you have got update random, let's say something like what we had discussed last week when we were there with Microsoft, like with OLTP systems, you have got data coming in every day, right? That I wanted it to be there. Typically it can be appended. Right now it's appended, fine. But then some of the rows can be updated also. So I don't want to have a daily feed which comes in. Hey, there's a difference between daily feed and an updated feed. Daily feed means always new rows coming in, whereas updated feeds would mean some of the old rows has to get updated. Okay, so if you want data streaming in on a daily basis, that is with some random updates in some of the old rows, that was row key that was there, you have to use your HBase. So that's the heart of it. So fundamentally, what is it? It's a platform for storing and retrieving data with random access. Means you can write data as you like, and it's up to you to read it back as you like. Pankaj was asking me, HBase is for structured or unstructured or both? Okay. HBase is basically for structured. Okay. It can be used for semi-structured data and even unstructured data to some extent. Because the beauty of this thing is, as you rightly pointed out, okay, in Pig there is no schema, whereas in Hive there is a schema, right? So similarly, there is no schema in HBase. So that means it can support unstructured data also, but then it is not going to support huge volumes of unstructured data. So that means you would need to do a proper capacity planning when you start with your HBase. You need to understand what is the percentage and unpercentage. Okay, that is the caveat that we have here. But then it is both for structured, semi-structured and unstructured. Why unstructured is possible? Because there is no schema that is involved here. In Hive, you have got a schema, right? So that's the reason why you can't use unstructured. It doesn't have a schema, that's why you can use structured. Sorry, you can use unstructured. Hive also is for unstructured, but then as it becomes heavy, then you would need more horsepower to make it run Pankaj. Hope that is clear for you, friend. Fantastic. So, like I said, yeah, the last part you could see, HBase stores structured and semi-structured data naturally. So you can load in with tweets and parsed log files and a catalog of all of your products right along with their customer reviews. It can store unstructured data too, but not, as long as it's not too large. So that is what is at the heart of HBase. Let's move on. Now let's look at the difference between what we typically have OLTP versus OLAP. So typical OLTP systems are used for reading transactional information at real time, wherein they are supposed to give responses quickly, typically in milliseconds. So when I say transaction, it refers to transaction in the context of databases. Okay, it's nothing to do with the financial thing. So that's why it's called as online transaction processing. Transaction is with reference to the data layer. So that is what is OLTP. So we are not even talking about replacing OLTPs right now, guys, okay? So OLTPs are good, databases are good. You want some quick answer, you can create indexes in your database, and that's how it will work. When we talk about OLAP, OLAP systems are used to answer analytical queries about the data stored in them. That's why it's called as online analytical processing. That is, this is again near real time, okay? So OLAP goes into the world of business intelligence, where you have got a cube concept, you have got fact, okay? Even in data warehousing, you have got cubes and facts and all that, okay? Where data is explored, processed and analyzed so that you can take information out of it which can be used for improving your business decisions. So that's your logic of your OLAP. So what is Hadoop? Where does Hadoop fit in? Hadoop fits in a kind of online analytical, but then it is more as a batch process, okay? So you do something on a daily basis. It's a kind of a batch processing system. So Impala, like I said, IMPALA, that is used by, that was introduced by Cloudera. So that is coming under the near real-time world nowadays. So that's a very high difference between your OLAP and your OLTP. So relational database, we know that there are basically open source and proprietary versions have been successfully used to scale to resolve both of the two above use cases. That means OLTP and OLAP. So both of them have got databases. Okay. We had Srilal who was mentioning, just to clarify, we move files from local file system to Hadoop, where the file and data is distributed in HDFS. So HBase is a database that can be created on Hadoop. I'm considering Hadoop as an operating system here, and the data stored in HDFS will be loaded into HBase and queried like SQL. Exactly. See, even HBase requires some file system to load the data, right? It could not have been better. What do you call explain, Srilal? So I am just going to send, or whatever you just typed right now. Okay, what happened? I'm going to send it across to everybody because you have put it in a very nice way. So let me, hey, why it's just showing me just to clarify, I don't know. Let me see if I can increase the width of this window. So for some reason I'm not able to copy what you said. So I'll just read it out. Hey, okay, it's below that. Just to clarify. Okay, Control C. Control C, and I'm going to say Control V, and I'm going to say send it to all. Okay, good. So this is what Srilal had to say. So you are quite right in that, Srilal. So HBase is going to be sitting wherein all the data is going to be there. At the end of the day, it is going to use Hadoop itself. But then the problem with HBase is that it requires a kind of master-slave architecture like what is being used by Hadoop itself. Okay. So with Hadoop, once the Hadoop ecosystem is there, HBase becomes the natural columnar database inside that. Hope I'm able to connect, Srilal. You're welcome. So let's continue. So like I said, relational database have been used to successfully to scale to resolve both these things. So what's happening in the internal design of your relational database is driven by a relational map, okay? And these systems requires an upfront definition of schemas and types that the data will thereafter adhere to. So this is what is called as schema on write. For example, when you insert something into MySQL, if the data type is wrong, it will throw an error at that stage. Okay. Whereas if you look at some of the NoSQL world like Cassandra or like HBase, okay, you will see that, or else for that matter, Hive is also schema on read and not schema on write. So it creates or validates the schema only when you want to read something from it, because you are given a table and an SQL-ish approach to the data that you have. That was for the structured data. Okay. So this is how schema on write and schema on read would be different. So over time, SQL became the standard way of interacting with systems, and it has been there for ages. So no doubt about this relational databases. Then came the big data world. Okay. So big data fundamentally changed the way we are going to think about data and how it is going to drive business values. So traditionally, your OLTP and OLAP were all on the recorded data. Okay, so big data changed the way how we are going to look at it. Because we're saying, can Impala query HBase tables? I'm sorry, because I haven't played around with Impala, because see what happens, a lot of these new projects come in, but then unless there was a need, because even now, even though Hadoop is batch oriented processing, people are still happy to use Hadoop as a batch processing because it gives a lot of value add. So I haven't played with Impala, so sorry I wouldn't know about that, friend. Okay. So, but then what was happening with the big data, the way it came? Okay, you're welcome, Vikas, and thanks for the understanding. So the way the big data changed is because while not much was done to understand the reasons behind the transactions or what factors contributed to the business taking place the way it did, or come up with insights that could drive customers' behavior directly. So we were talking about data. So what data are we having? We are having customer ID, customer name, amount that he bought, okay, and whether he paid by cash or credit. That's all data what you have. But nowadays, there's a lot of sentiment analysis what is happening on that. So the metadata that was around it. So nowadays, a common question what people are asking is, do your credit companies know you? There is something called as know your customer, right? KYC. So KYC is another aspect of your big data initiatives. Almost all banks and RBI has now made it mandatory that you should have KYC, right? But then that is again limited to something. So you should know exactly what is your favorite thing. Like for example, I don't know whether have I given the DBS Bank example to you folks? One of you can answer that. The Singapore DBS Bank, have I given an example of that to you before? Okay, Pankaj says no. Fine. So let me take it up. Okay, even Pani says no. So I was involved with this DBS initiative because when I was in progress, we were talking about Apama, and DBS was using that to as a big data and as an analysis platform. So what happened with DBS was that they see. There's a lot of end users who will use DBS, but then as a value add, what DBS wanted to give was that they wanted people to use, see, at the end of the day, what does a bank want? People should use their credit card more, okay? But then how do I make them use a credit card more? By maybe giving them a discount. Okay, I am in, I use DBS Bank. I am in Mumbai. I'm in Hyderabad, let's assume next week. And DBS sends me an SMS, hey, in Mumbai, there is a discount on this item for so-and-so. I'm not going to fly down to Mumbai for using the discount, right? So that is what is called as untargeted marketing. Okay, now comes the world of targeted marketing. So how does that happen? So what DBS did was that near real time, whenever you swipe the credit card, okay, so then you realize that, hey, this person was there at this shopping mall, okay, and what DBS did was that immediately, if they check the timing between 11:30 to 1 o'clock, if you have swiped your credit card at a shopping mall, okay, they come to know when you swipe the card, they'll get all the information. They already have got the customer preferences, okay, they will send you back a SMS. Okay, they have the phone number, of course, your phone number also. They will send you back an SMS, okay, which will say, hey, since you're there at this mall, thanks for using DBS credit card. As a matter of gratitude, we will give you a 15% discount on a specific chain of food items at this shopping mall. So typically when you're going for shopping, okay, and that also they were looking at the amount of items that you bought also. So they know that, okay, what all things you have bought, what are the things, okay, so they will give you the discount. So typically when you go for a mall, typically you want to eat outside. So when you get this, you go down over there. As a targeted marketing, they know the mall where you have bought it, and they also know what is your preferences. So if you are into, let's say you're a big follower of football or something, and Chelsea has come out with some new marketing stuff, okay, they will give you the Chelsea marketing opportunity also. So this is how the targeted marketing was happening with DBS, and they realized in 6 months, okay, their usage of their DBS credit card went up by 540%. So just one example of how we could do that. Let's try to apply the same thing in India. It would be wonderful, guys, right? But then unfortunately, India has got a long way to go, friend. But then this is some example of how big companies want to use the big data to get some information out. So all of these things can happen only when you do it at a real quick basis, right? I can't, you swipe my card after half an hour. If I send it to you, I would have already got into my car and I would have come out of my mall, right? So that's why near real time is what is important nowadays. So just to give an example, So let's move on. So that was the big data aspect of it. But on the contrary, we can have Hadoop as a batch processing system. Yes, very much. So that is what companies are already doing it right now as a batch processing, and try to build in the real-time and close to real-time aspects of it. So now what was needed was, then came the dawn of the big data systems. So they needed some systems that could work for different kinds of data formats and sources. I want to have tweets, I want to have click streams, I want to have weblogs, without requiring its strict schema definitions upfront, and to do it at scale. See, the advantage of HBase was that I'll come back to you, Vikas, on that. Give me a minute. So the advantage of HBase is that right at the beginning, it was decided that scale is a factor, whereas scale is something what is come as a second thought or as a supplementary thing in most of the evolution of systems, guys. So here they decided that, hey, scale, I want to scale up quickly. So scale was something at the heart when they wrote the code of it. The requirements were different enough that going back to the drawing board makes sense to some of the internet peers, and that's what they did. So that's how the world of big data systems and NoSQL came about. Just giving a history. So Vikas was asking me, on the contrary, we can have, can Hadoop a batch processing system? Doesn't that mean that it, hey, Vikas, you're saying that you would like to speak out, wonderful. So let me go ahead and I can unmute you, friend. You are unmuted. Please speak up, Vikas.
Yeah, I was just going to say that we generally call Hadoop as the batch processing system.
We can't hear you, Vikas. I'm sorry.
Is it any better? Hello? Can you hear me?
Okay, Pankaj can. Okay, sorry. Speak a little bit louder than maybe.
Can you hear me now?
Yeah, go ahead.
Okay. I was just saying that you gave the DBS example, but on the contrary, we generally call Hadoop as the batch processing system, which implicitly means it's probably like not real time and hence maybe slower. So the example of DBS and the usage of Hadoop was a little contrary from my context. So just wanted to get a sense of.
Exactly. So that's why I said what DBS had used, I was giving you more, not from the Hadoop perspective, I was giving you this analogy basically from the perspective of usage of big data. It was from that perspective I was giving it, and DBS was not even using Hadoop, they were using Apama. Okay, that is our Progress software product. They were using Apama to get this real-time analysis done and then do it. Hope that makes sense.
Okay. Yeah, definitely does. Thanks for clarifying.
Okay, wonderful. Thank you, friend. So I'm just meeting him, Vikas, back again. So I was not saying it from the Hadoop usage. I was giving it more from the way big data will help you, friend. Since you're talking about big data, I gave you that example. So even now Hadoop, with Impala coming in also, it is going to be near real time is what people are saying. But then we still need to see how do we use it. Okay. Fantastic. You could still use HBase. There's a couple of use cases that I'm having coming up in the slides. You will see how HBase is used nowadays, or in quite some time with what Facebook is using it. Facebook Messages is using HBase. You'll see that. Cool. Thank you. So that was how the big data systems came about. So it was at the same time that Google published its white paper on the big data on Bigtable, which provided a complement to the storage paradigm provided by its GFS, Google File System. So as Google Publications provided insight into indexing the internet, because everybody is talking about the search, right? So if you want to index the internet, at the same time Amazon published Dynamo. That was their in-memory database, okay? Published Dynamo, which demystified the fundamental component of a company's shopping cart. So see, some people used to share whatever was their thing, some people were not, and whenever you get some new idea, it is typically the open source world which catches it quickly and starts developing things, okay? So the same thing happened, the NoSQL started flourishing. let's talk about the history, continue with the history. So that's how Bigtable came about. So this is to continue with the history. So in the years following, the data management space has come to host all types of projects. Some focus on fast key value stores. People call HBase also as key value store because there is a row key, whereas others provided native data structures or document-based abstractions. Equally diverse were the intended access patterns and the data volumes each of these different technologies support. Some of these what we call initiatives forgoed the right of writing data to disk, that was called as in-memory databases, sacrificing immediate persistence for performance. Most of these technologies do not hold ACID guarantees as sacred, so there is no ACID properties as such. Although proprietary products do exist, what majorities of the technologies are open source projects. Thus these technologies are come together as a collection to be called as NoSQL. That is not only SQL. Okay, so that's how the NoSQL world came about. Just to give you a history, I came to know about this last week from Microsoft. SQL Server has got a new way by which you could have column families. You might not know what is column families right now. I am not specifying why is it called as column family, because a family, different data types can be stored in that particular column. Okay, so the column families and the column indexing concept is something that has come up in SQL Server 2013. I came to know about it last week. So why is SQL Server also trying to get into this stuff? Because columnar databases are pretty much fast in data retrieval. Okay, for random writes and random reads, columnar databases are the best folks. Okay, so just wanted to share this with you. Microsoft is really doing a lot of things to ensure that it is coming in touch with the world, what the open source world is coming to. Okay, so let's move on. So that was the NoSQL part of it. So now the question comes, typically, even Microsoft asked that, hey, you're talking about HBase. So is HBase a NoSQL? So where does HBase fit in? HBase does qualify as a NoSQL because there is no schema. It provides a key value API, although with a twist not common in other key value stores. Okay, so the biggest advantage of HBase is that it promises strong consistency so that clients can see the data immediately after it's written. HBase runs on multiple nodes in a cluster instead of a single machine. Okay, it exposes this detail, although it doesn't expose this detail to the clients. See, Google knew the advantage of distributed file system. The same concept they applied to HBase also, wherein you have got multi-node clusters. Okay, so although when we said file system, the file is split into different nodes. Here, HBase was also a concept. Bigtable was also giving you the impression or the way how you could put the data across into multiple different nodes. So let's take an example. Your application code doesn't know if it is talking to node 1 or node 100, which makes things simpler for everyone. It's a part of the Hadoop ecosystem and depends on some key features like data redundancy and batch processing, which will be provided by the other parts of Hadoop ecosystem. Okay, so in that way, give me a second, please. In that way, HBase is not a part of the NoSQL. Okay, it differentiates from that, but then it doesn't talk about the schema part of it. Okay, so hope it's clear, guys. Can I get a quick response from the others to see whether the history that I'm talking about HBase is making sense, folks? Because it's very important that you should know why HBase came. Because I have taught this many times. Thank you, Sandeep. Thanks, Vivek. Thanks, Pani. Thanks, Pankaj. I taught this many times, but people were not clear about why do I need HBase. Okay, I can do everything with Hadoop, but Hadoop is worm, whereas for random reads and random writes with a database, it's good. Yes, you will see use cases, and after that, examples with us. So let's continue. So who created HBase? like I said, Mike Catafella, released a code for an experimental open source big table, and he called it as HBase. Okay, Hadoop base. So the startup PowerSet decided to dedicate two gentlemen who are one of the most important contributors to the HBase community, that is Jim Kellerman and Michael Stark, to work on this big table analog as a way of contributing back to the open source community on which it relied, because it picked it up from Google, which is there in the open source community. Okay. Now let's look at the use cases. Okay. So the most common use case is a search, that is the canonical web search problem. So what happens in the search is there is a huge amount of data, right? There's a huge amount of data and corpus of documents. So big table, and now HBase, big table was for Google, so and by extension HBase, provides storage for the corpus of documents required by this search. So big table supports row level access so that crawlers can insert and update documents individually. Okay. The search index can be generated efficiently via MapReduce by firing a code directly against big table. Individual document results can be retrieved directly, and support for all these access patterns was the key in influencing the design of big table. So this is where the heart of the thing comes in. So one, while Hadoop was write-only read many times, these web crawlers or the search engines know that I have to keep on changing, right? So I am changing my address today. Some new search criteria comes up. So they will have to, for that search, they will have to change the row level access so that they can, the crawlers can insert and update the documents. So that is possible. You have to have a quick search index, okay, that can be generated efficiently via MapReduce. That's the programming part that I'll be talking next week, directly against Bigtable. Good. So let's continue. The next thing is, which all companies are using it? So HBase at companies, a technology designed to store a continuously updated copy of internet, turns out to be pretty good at other things internet related also. So anything that requires updates, HBase is pretty good, and huge data. Okay, so HBase has found a home filling a variety of roles in and around social networking companies, from storing communications between individuals to communication analytics. Okay, so HBase has become a critical infrastructure at Facebook, at Twitter, and StumbleUpon. These are some of the companies that is very crucial. Hey, Pankaj was asking about a little bit more explanation on a crawler. A crawler is something, see, if you have got a website, Pankaj, okay, you would have that website decided by some keywords, right? So web crawler will quickly look at the keywords. Like, for example, when you say Venkat, it will go down and displays all Venkat for you, right? If you say Venkat and Hadoop, it has to do a join between the all searches for Venkat and all searches for Hadoop, right? Okay, so web crawler goes to each of the keys and keeps on indexing. Somewhere there is an index which says Venkat, okay, these are the pages, these are the websites where those information is. Okay, so that is web crawlers. Typically web crawlers gets updated once in a day. So if I make some changes in my website, if you look at a cache copy of it, it will look like the old one. If you look at a new copy of it, it will be my latest site. Typically Google updates it every couple of hours. Okay, other search engines update it every day, 24 hours. So that's what is a web crawler. Okay, hope that is clear, Pankaj. Wonderful. So what happens in Twitter, I have got somebody who will tweet something, and I have got my relationship also, right? If I tweet, it should automatically go down to somebody else also. Okay, I have got, if I like it something, it should go down to some other people also whom I have, who are subscribed to me or who are following me also. So it becomes very crucial or very complex, you know, very soon, all of these infrastructures. Okay, so let's continue with the story. So this is what it's using. Now let's look at this diagram. This is up to you guys. Have a look at this diagram and we will discuss this. Just once again, I think some part of the diagram is spilling out. So just to be clear, I want to make this up a little bit. Okay, and let me put this into the slideshow. Oh, sorry. There it is. And you'll see something of crawlers here also. Hey, Srilal, I was just waiting for you to have a look at this diagram. There are 5 steps inside it. So just go through this, folks. Okay, so I hope this is clear. Typically what happens, like I said, it's a database, okay, which is sitting on top of Hadoop. So anything that happens, frequent updates are made to the big table. You can write a MapReduce program on that which returns a search index. So when the web searches something, okay, they look at the search index, and for the value of those indexes, they go back to the big table where there would be key value pair, and the documents are directly retrieved from big table. When I say big table, that means again talking about the HDFS as the file system, and then the search is presented to the user. Folks, hope this is clear. A quick yes from the participants would be wonderful. Thank you. Hi, Nishant. Thank you, Gaurav. Okay, Nishant says okay, that's good. Wonderful, guys. So this is what is the concept of Nishant, were you there from this batch or from some other batch, friend? Because maybe I'm wrong, but then I did not. Okay, wonderful, Nishant. No worries. I did not immediately recognize you. So no worries. So this is the concept of your web crawlers and how it works with the search engine in conjunction. So the second use case after that canonical web search would be in cases where the data trickles in and is added to an existing data store for further usage, such as analytics, processing, or servicing. If you want those kind of architectures, the edge-based use cases fall beautifully in this category. So you could use HBase as a data store that captures incremental data coming in from multiple data sources. Yes, there is a way how to use Scoop and all that. You will see that later on, but that's for an RDBMS. But then if you want to have incremental data coming in, your HBase is going to be a fantastic fit for that, friend. Lovely. Another example. So StumbleUpon has come up with a concept called as OpenTSDB. We will look at what is that. Okay. So as a history to it, web-based products servicing millions of users, okay, typically have hundreds or thousands of servers in their backend infrastructure, which do a lot of functionality, like take care of the serving the traffic, capturing logs, storing data, processing, so on and so forth. So to keep the products up and running, it's very important that you monitor the health of the servers as well as all the software that is running on them. Okay, so right from the OS stack to the application stack. So monitoring the entire stack at scale requires systems that can collect and store metrics of all kinds from these different sources. Okay, so this is continuing with the same story, incremental data from different sources. So StumbleUpon, this company OpenTSDB is from StumbleUpon. You'll see what is this TSDB in the next slide, folks. Okay, so that's the history. How do I capture metrics? The framework that StumbleUpon built is called as OpenTSDB, which is Open Time Series Database. which is a framework which uses HBase as its core to store and access these collected metrics. Okay. The intention of building this framework was to have some kind of extensible metric system that could store and make metric be available for access over a very long period of time, as well as allow it for all sorts of new metrics to be added as more features are added to the product. So StumbleUpon uses this open time series database to monitor all of its infrastructure and software, including HBase clusters. Okay. So just wanted to check with you guys, have you heard about the new video about 2 weeks back that has come from Stanford University on big data? Did any of you got a chance to have a look at that? Nishant says no, Pani no. Okay, so please go ahead to go to YouTube, Stanford University crime prevention, search with that, you'll see this video. So what are they saying is, okay, I can definitely send an email and I'll share that link of the YouTube with you. Okay, same thing with you also, Pani. So what happens here is, they are in a position where they can actually predict a crime. The San Jose University are using big data, okay, to have some analysis by which they can predict. So this is used for predictive analysis, we know that, okay. So they are using this so that they can predict when a particular time some crime can happen, guys. So that is the extent to which they're using it. Another use case, while I was with DBS Bank, I got a chance to speak to Sington people, that is Singapore Telecom. They use your analysis. A storage is what is Hadoop basically. Singtel uses Hadoop. Okay, so they use the analysis to predict when a network failure can happen, when there's a probability of a network failure. Okay, so that is the extent to which people are using these analysis. Same thing StumbleUpon. They take up these things. They put in the information of when did a service fail or for what reason the service failed, and then they try to extrapolate it and say, hey, when is this likely to happen again? Okay, so Stanford University, if you go down, there's a group, and I think, once again, let me just quickly do it. Should not take more than a minute. Okay, so I'm going to go down to youtube.com while we are doing it, because this is a must watch. You know, it's wonderful. I thought people would have seen it, otherwise I put it in the group, you know. And I am just going to go down to the search. Come on. Why in the world am I not able to search? Yeah, there it is. Stanford University crime prevention. Okay, let me click on this, and or else I'll send you the link, guys, because I am a member of this. Yeah, let me click on the Stanford University. I'm a subscriber to them. So I don't want to waste too much of time, guys, but then I found this to be fabulous, you know. Yeah, there it is. Using big, no, not this. This was before that. There was a big use case on how to use big data at Stanford Medicine also, right? Okay, so that was another of the use cases. Sorry, guys, I don't want to waste time on this. I will put it in the LinkedIn, Edureka LinkedIn group, guys, okay? So that you can also have a look at that. So let's continue. Let's not waste time. Okay, go ahead. So that was an example of capturing metrics. That was your StumbleUpon. Let me go ahead to the next one. Again, how do I capture the user interaction data? So metrics are captured for monitoring are one category. There are also metrics about user interaction with a product. How do you keep a track of a site activity of millions of people? And how do you know which site feature is more popular? How do you use one-page view to directly influence the next? For example, who saw what and how many times a particular button was clicked. So this is like the like button in Facebook and the stumble and plus button in StumbleUpon. So does this sound like a counting problem? Yes. So they increment a counter every time a user likes a particular topic. So the user interaction on a page is also captured so that you know what has it been used. Because at the end of the day, the social media has to be really innovative, guys. So let's look at Facebook for this. Okay. Facebook uses counters in HBase to count the number of times people like a particular page, so that content creators and page owners can get near real-time metrics about how many users like their pages, so that they can make some decisions about the content to generate. Facebook built a system called as Facebook Insights, which needs to be backed by a good storage system. The company looked at various options, including RDBMS, in-memory counters, Cassandra, and now they are using HBase. So this is just to give you an idea of how companies use this. Again, let's talk to the other two major users of it, that is Mozilla and Trend Micro. So while operational and software quality data include more than just metrics, okay? So like, for example, a crash report. It's an example of a useful software operational data that can be used to gain some insights into the quality of the software, and you can plan for development roadmap. HBase has been successfully used to capture and store crash reports that are generated from software crashes on users' computer. So let's see how Mozilla does this. So Mozilla is used for its Firefox and for its Thunderbird, right? So these tools are installed on millions of computers and run on wide variety of OS. So when one of these tools crash, a crash report is sent back to Mozilla in the form of a bug report. So how does Mozilla store all of these things? What use are they once collected? The reports are collected via a system called as Socorro, okay, and are used to direct development efforts towards more stable products. The data storage of Socorro and analytics that Mozilla is using are built on HBase. So there is frequent updates and random reads. Continuing on with the same story, Trend Micro, they're basically a antivirus company, started with that, okay. They provide internet security and threat management services to clients. The key aspect of security is awareness, and the log collection and analysis are critical to providing the awareness in the computer systems. So Trend Micro uses HBase to manage its web reputation database, which requires both row-level updates and support for batch processing with MapReduce. So you see here there is a real-time aspect also coming over here. Okay, you can do that. Plus, you will have your batch processing with MapReduce also. So much like Mozilla Socorro, your HBase is used to collect and analyze log activity, collecting billions of records every day. The flexible schema in HBase allows data to easily evolve over time. Okay, it doesn't throw away something because the data type is not clear. Okay, and Trend Micro can add new attributes as analysis processes are refined. So just some examples of how people actually use it. Just three more examples, and then we will get down to the architecture. While I developed this, I thought that these are things that is must for you to understand, folks. So that's the reason I have made it a little bit lengthy theory, but then you should know how and where it is used. Others are all very clear, Pig, Hive, but HBase is something which is always what I call confusing. So that's why I thought I'll put some more stuff onto it. Again, ad impressions and click streams. So we know that online advertising has become a major source for revenue. Okay, they provide free services to users, but have ads linked to them and that are targeted to the user using the service at once. A simple example is Edureka itself. Okay, they use a lot of click streams. So this kind of targeting required detailed capturing and analysis of the user interaction data to understand what is the profile of the user. The ad is to be displayed to them is then selected based on that profile. Of course, you can have fine-grained user interaction data can lead to building better models so that your ad targeting at the end of the day is good and you get more revenue. Okay, so but this has got two datas. One, it comes in the form of continuous stream. and it can be easily partitioned based on the user. So typically in a good world, this data should be available as soon as it is generated so that the user profile models can keep on changing it without any delay. So like a kind of an online fashion. Okay. A vast amount of content. So where does Hadoop, where does HBase come into picture in the last example? It helps in continuous update of your profile because you want to have row level inserts over there. That's what I was trying to bring it to you over there. So that was an example of, let me just go back, add impressions and click streams. The next important area is content generation. And whenever I say content generation or content aggregation, all of you know Salesforce. They also use HBase at the back of it. Okay, so let's look at this. So you've got a large amount of content available that the users may want to consume and interact. So in addition, the access to such applications have been growing, okay, because of the internet. So there are various kinds of devices lead to other requirements. Different devices need the same content in different formats. Okay, so now I don't know whether you are aware of it. We have got in the mobile world an issue called as cross-platform compatibility. So using HTML5, okay, and CSS3, you can get this kind of cross-platform compatibility. So you could develop something on Windows 8. The same thing you could make it work on your iPhone. You can do something on Windows 8 touchscreens. The same thing will work on tablets also. So that is what is the concept. So that is HTML5. So while I read it, I thought I'll share this with you. So that's about user consuming content. In another entirely different use case, user can generate content also, like tweets, Facebook posts, in Instagrams. Remember my day one when I spoke about Instagram and microblogs are some of the few examples. So whenever you talk about content servicing, okay, take an example of Salesforce. When looking for ways to expand its database arsenal to include distributed database systems, Salesforce evaluated the full spectrum of not only SQL before deciding to implement HBase. Okay, what was the primary reason they chose this? This was for consistency. So they have got big table style systems are the only architectural approach that combine seamless horizontal scalability with strong record level consistency. Additionally, Salesforce had already used Hadoop for doing large offline batch processing. So the company was able to take advantage of the in-house expertise in running and administering systems on the Hadoop stack. So some of the examples, I think I have got two more and then we will finish this. There's something called as URL shorteners, right? You know that, TinyBit. Okay, so URL shorteners have gained a lot of popularity in the recent past, and StumbleUpon has got something called as su.pr. That uses HBase as its backend, and that allows it to scale up, shorten URLs, and store tons of short URLs and their mappings to the long version. Okay, because at the end of the day, when you give a tiny URL, you still need a link where it should go when that is called, right? Okay, so that is what is the concept of URL shorteners. The next thing is coming back to the earlier structure of user models. Often the content being served out of HBase is not consumed directly by the users, but then it is instead used to make decisions about what should be shown to the user. It's metadata that is used to enrich the user's interaction. Okay, so we spoke about user profiles in our ad targeting last time, right? So there's a company called as Runa. It's called as Runa.com, okay, which serves user models that are used to make real-time price decisions and make offers to users during their engagement with an e-commerce portal. So these models are fine-tuned continuously with the help of new data that comes in. So what is the biggest advantage, folks? You would see that, yes, with more data, I will have more precise accuracy. Limited sample data, I can't have that kind of a control. So you could use your serving user models also. And the last two things, information exchange. So if you're on Facebook or you have likely sent or received messages on your Facebook, there is the whole of the Facebook, the way it works is entirely backed by HBase. all messages that users write or read are stored in HBase. The system supporting Facebook messages needs to deliver high write throughput, extremely large tables, and very strong consistency within a data center. So in addition to messages, other applications have got requirements that influence the decision to use HBase. So some of these things are read throughput, counter throughput, like I said, you can increase the number of counters, and automatic sharding are the necessary features. So what do you mean by sharding? Splitting across multiple nodes. So the engineers found that HBase to be an ideal solution because it supports all of these features. It has got a good active community, and the Facebook's operational teams had experiences with the other Hadoop developments. And now the last slide of the history. So Facebook engineers have shared some interesting scale numbers at the HBase Con that was done last year. Billions of messages are exchanged every day on this platform. And the summary is about 75 billion operations per day. At peak time, this can involve to about 1.5 billion operations per second on your Facebook's HBase clusters. From a data size perspective, Facebook is adding about 250 terabyte of new data to its clusters every month. I already need to have its old data, right? Okay. So this is likely to be one of the largest known HBase deployments out there, both in the terms of number of servers and the number of users the application in front of it serves. Wow, so that was some history, guys, right? Well, I am tired, man, of continuously talking, but I hope you would have understood where HBase is used and how it is used, guys. No, because it was using Cassandra earlier, and then they had moved on to HBase. They use Cassandra also in some locations, Vikas. Fine. So now let's look at this architecture. So like I said, HBase would need a server like HMaster. Okay. What is the purpose of the HMaster? It has to assign. Okay, let me go back. There was one question. Hey, you're most welcome, Vikas. No worries, man. So HMaster is like your name node, which assigns regions, that is data, to region servers. Region servers, again, a wrong name like secondary name node. That's actually the slaves. Region servers are actually the slaves. Okay, so they check the health of the region servers. Okay, so typically, what will the client do? Client will look up at the root. Okay, you need to have a Zookeeper running for HBase to work. Zookeeper is a kind of a coordination environment. So in the first simple example, we don't need to do anything on Zookeeper, but when we get down to Java, you will have to use a Zookeeper, like you see client. So client, look up the master root to the Zookeeper, registers the HMaster location, the root locations with the Zookeeper. So the client will always talk to the Zookeeper, and client will rarely talk to the HMaster directly. Once he gets the listings, the client will read and write data from the region servers. So region servers are like our data nodes, exactly almost the same like what we have done in our Hadoop architecture. So then you have got region server 1, which will have various regions, that is nothing but tables, and the client will read and write from these regions, folks. So this is a quick architectural base of HBase. So any questions, folks, till now? Okay, nothing from anybody, so I presume, yeah, thanks, Pani. Yes, this has to be on the cluster. So that's what. So that's, no, it's not like Pig. You need to have HBase on the cluster, because HBase will use the fault-tolerant mechanism of Hadoop to take care of a lot of things. So that's why, as a hand-in-hand, both of them complement each other. This is not like Pig outside the cluster. This has to be on the cluster, because. Okay, so after HBase, there would be nothing called as JDBC connectivity. JDBC connectivity would be there in Scoop. okay, not an edge base. So you see on the top there is something called as zookeeper, right? So it's the client will have to talk to the zookeeper to know the edge master details for getting the data. Replication, Pankaj is saying, what about data replication? Data replication typically to some extent is handled. As you go ahead, you will see how it's done, but then it will handle more to do with the Hadoop ecosystem. Okay. So if something is there in a block level in Hadoop, yes, it would be replicated, right? So that's the way it would happen, friend. Wonderful. So let's move on. Thank you. So like I said, what is HBase? It's a sorted map data store. It is not a relational database. It's very light schema. Table consists of rows. Each row will have a primary key that is typically the row key. Each row may have any number of columns, like a map, byte array, and the rows are stored in a sorted order. HBase is also called as a columnar database, okay? So we will see why is it called as a columnar database very soon. But then there's a row key, there's a primary, indexing happens on the row key always. The columns can have one or multiple columns, okay? So that's the way HBase is very forgiving. When you try to when you insert something, you typically specify a column family. You don't specify a column. So you can put in a number, a integer, a regex expression. It is very forgiving. It will take all of those things. You'll see it in an example, guys. Okay. So it's a kind of a sorted map data store. So if you look at the HBase storage model, it's column-oriented database. Okay, the column name is arbitrary data, can have large variable number of columns per row. The rows are stored in sorted order, like I said, and you can have random read and write over here. So that's your storage model for your HBase. So let's look at what's columnar database, another new term. Okay, it's because of this people think that this is NoSQL, not necessarily. So in a columnar database, this is a database where the data is stored in columns instead of rows. So it is simply swapping it, okay, what we typically do in RDBMS. The goal of the columnar database is to efficiently write and read data to and from hard disk storage in order to speed up the time it takes to return a query. In a columnar database, all the column 1 values are physically together followed by all the column 2 values and so on. This allows individual data elements to be accessed in columns as a group rather than individually as a row. And that's what is the trick to its speed also, friends. One of the main benefit of this is that data can be highly compressed. So any of the columnar operations like min, max, count can be performed really very quickly. The other benefit is that because of the column-based DBMS is self-indexing, it uses less space than an RDBMS containing the same data. Okay, this is also a historical trend. Okay. Now let's see some examples of it. There you go. So I'll give you some time to look at this and then we will discuss this. About a minute or so, 60 seconds. Please go ahead, friends. Thank you. Okay, so just to let you know, if you are going to look at this as a logical view as records, the row key is the implicit primary keys if you look at it from the RDBMS perspective, and the data is all byte array in HBase. Okay, there are in the data, there are two column families. There is a column family called as info and there is a column family called as role. Okay, you can have multiple values in the role. There would be a key and there will be a value of that. Okay, so different types of data separated into different column families. Different rows may have different sets of columns. Okay, the table is sparse and a single cell might have different values at different timestamps. By default it stores 3 timestamp values. So this is the logical grouping as a record for your HBase tables. If you look at the physical value, so in the info column family you had a row key, you had a column key, okay, and you had a timestamp and you had a value. Okay. Similarly for the roles column family, what are the different roles, what are the timestamp and what are the cell values, and rows are sorted on disk by the row key. Okay, column key, and then if you want any descending way of timestamping. So this is how your columnar database would be. So if you see the logical record versus the physical record, you would know how this would look into. Wonderful. Now, how do I access HBase? One, you can access HBase using a CLI, okay, that is client level interface. Because each column is a HBase table, no, let me go back. Okay, this whole thing is an HBase table which has got row keys, which has got data, which has got multiple column keys having multiple values. Okay, so the next diagram is what may put you off, but then there I'm just showing you how the it will look for every column, because hope it's clear. This is not intentional, this is not to put you off, but I'm just giving you more information on it, friend. Okay, that's it. So both columnar families are part of one table. Exactly, because that's right, because that's how it is a columnar database. Okay, wonderful. So next thing, how do I access HBase? There is a CLI for it. Okay, you can do it through Java API. That's what we're going to see next time. You could use REST API or Apache Thrift. Thrift is a open source project which has got multiple protocols. There is a client and a server over here. Any language can be used, or you can use both Hive and Pig for analytics also. Okay, so this is how your access models would be. Exactly. So in fact, if you do list, see, there is something called as get. If you say get, it will give you the latest time scan. If you say scan, it will list the whole contents of the table and including the earlier 2 old copies of the columns. It will give you 3 timestamps completely if you say scan. So that's the difference between columnar databases and HBase in particular, Vikas. Hope that makes it clear to you. Wonderful. Okay, talk about the high-level architecture. You can use it using MR or any of the Hadoop components, using Thrift or REST gateway. You'll have a Java applications, a client who will talk to the Zookeeper and who can talk. The HBase will also talk to the Zookeeper, and HBase at the bottom layer is having HDFS, which is the file system. Let's look at the terms now. I said something called as region server earlier, right? So a region is nothing but a subset of a table's row, like a range partition, and it is automatically sharded. Sharded means it is spread across multiple nodes. Region server is a slave. It serves the data for reads and write. Again, a wrong word, region server. Okay, and master is responsible for coordinating the slaves, assigns directions, detects failures of region servers, and controls some admin function. So a couple of different terms that we have. So if you look at the cluster architecture, okay, you will have the client. The client finds the region server details in the Zookeeper. Okay, so I have got something called as HMaster. Okay, you will have multiple clients, that is your Zookeeper peers. You will have a region server. Okay, multiple region server, there is multiple nodes all talking to HDFS. So this is how the column architecture of your Edgebase would work. Now let's look at what would happen if there is a big and there is a small deployment. So if you talk about a big deployment, you will have your HDFS, that is name node, you will have your secondary data nodes, and you will have your data nodes. So the data nodes, the task trackers, the region trackers are all going to be there on the slave machine. Of course, you will have some zookeepers also, and there will be something called as HMaster with one in a standby mode. Okay, so that's your big custom deployment model. If you're having a small custom deployment model or cloud deployment, your name node, secondary name node, your job tracker, your HMaster and Zookeeper will be in one node. The region server, the data node and the task trackers would be there on your client nodes. So I just wanted to separate between the big and the small deployment, folks. Now, the next set of 3 slides talks about trying to differentiate Edgebase with the different HDFS and with MapReduce, with database also. So folks, it's about, let's see, I would need a tea badly, friend. So it's about 4 o'clock right now. Let me check the actual time. Yeah, it's about 4 o'clock. How about taking a quick 5 to 7 minutes? Let's say take a 10 minutes break. Okay, so that would be needed because this is like lecture 1 where I have to do a lot of talking and not much of hands-on for you guys. So I think stretching out would be good for you folks also. So let's take up a quick break, and then how about coming back at 4:10? It's about 4:01 right now. 4:10, would that be fine? Vikas is liking it. Others, is that okay with you, friends? Thank you, Srilal. Thank you, Nishant. Wonderful, Pankaj. Yeah, great, Sandeep. So, thanks, Pani. So let's take a quick 10 minutes break. I'm just going to mute myself. We'll come back and we'll continue again. Okay? Thank you so much. Hi guys, I'm back. The break was necessary, that's good. Had a good break, good coffee, so very fresh. Thank you, Pani. Thanks, Vikas. So now let's go ahead and see, after seeing the architecture and the diagram, what is the difference between Edge-based and HDFS. Let me put this into the slideshow. So the biggest difference is the read and the write patterns. Okay, so first, in Edge-based you will have basically append-only write pattern, whereas in HDFS, in your Edge-based it can be a random write or a bulk incremental pattern also. Like, how do you get your data streamings in on a daily basis? The read pattern is basically in HDFS is a full table scan partition. Okay, whereas random read, small range scans or table scans is possible. Your Hive SQL performance is very good over there, and in Edge-based, because the data is sparse, it will be slower. For structured storage, it is do-it-yourself, sequence file, Avro, everything. It is basically a sparse column family data model. Max size is 30 petabytes, whereas in Edge-based, basically at a time you can have around 1 petabyte. So look at the point at the bottom. If you have neither random write nor random read, it's best to stick to HDFS. Okay, so that's something that we should keep a note of. So if you have something like random read and write, then only it makes sense to use Edge-based. Let's look at Edge-based versus the RDBMS. So data layout is row oriented in RDBMS. Here it is column family oriented. Transactions, multi row ACID. Here there's only a single row. Query, QL, you can use get, put, scan. Remember I mentioned these commands all earlier. Security is authorization, authentication, whereas work is in progress right now on the Edge-based. It uses Kerberos security. Okay, because when I say random read and random write, let's take an example. I have got an OLTP system, and in the OLTP system, you are, let's say there is a customer order. Okay, yesterday the customer order was in one stage. Okay, today it would have gone down to do different stages. So when I write it to it, I don't want to append to it, right? I don't want a new row to be added which will have multiple customer record status. I would want it to be one row where the old value should be replaced with a new one. So that is an update, right? So very common use case, OLTP kind of use cases. Updates when you want, it's better to use your Edge-based because Hadoop doesn't support updates, right? Even in data warehouse, you don't have much of updates. OLTPs have got a lot of updates. Exactly. Random write or is equal to update. Yes, that's right. That's exactly what we're talking about over here. When I say random write, it's typically an update. Make sense? And when you want to read something, you want to read a particular row. So there is nothing called as a row concept. Yes, you can Hive and give it a structure and all that, but then if you would want, look at the reads that we have in the last, when we talk about Edge-based versus HDFS. Let me go back one slide. Look at the read pattern. It is a full table scan. You can read a partition. Here you can use random read, small range scans or table scans. Okay, so that would be the actual difference. In fact, Pani, this has been there for a long period of time. So where you want schema on read, you don't want schema on write, like the NoSQL kind of stuff. So data applications are moving a lot to Edge-based kind of databases. So that's why Cassandra and the NoSQL is what is very popular, right? In-memory databases, Memcache and all that. So there is already a trend in all of these things moving to these kind of databases almost a couple of years now. Okay, wonderful. So I hope that is clear, both random read and write, Vikas. Okay, you're welcome. Now, again, we were there, we didn't finish this. So if you look at security, Like I said, it's the work in progress. Indexes are on arbitrary columns. Indexes are, it's automatically indexed based on row key. So it's in good in one way, okay, it's in bad in one way. You can index some columns. Your max data size can be TBs, this can be petabytes. Your read-write throughput is, this is where it beats the RDBMS black and blue. The throughput limits can be 100 seconds, 100 second queries per second, and here you can have millions of queries per second. Okay, so the throughput is going to be wonderful because of how the way it is being shredded or spread across the different nodes. Okay, so this is the difference between your database and your HBase. Now let's look at HBase over NoSQL, other things. Okay, so first, it favors consistency over availability. Okay, but availability is good in practice. Okay, it has got a very good Hadoop integration, very efficient bulk loads, map reduce analysis, etc. The range partitions are ordered, okay, like row keys, what we said, not just hashed. It automatically scales shreds, that is, just turn on more servers. Balancing will happen automatically, like how balancer happens in Hadoop. And it is a sparse column storage and not necessarily a key value pair. So that's between HBase and Cassandra specifically here, or in general all the NoSQL databases. Okay. If you look at the largest cluster, we have got 700 nodes, about 700 terabytes, 5 to 20 nodes, 100 GBs to 4 terabytes, and if you talk the cluster perspective, then you will have, how is it, 1 to 3 minutes, you'll have 1K to 10K writes per second per node, reads 0 to 3 milliseconds, okay, cached 10 to 3 milliseconds on disk, 10 to 4K reads per second per node from cache, and each individual cell size can be 0 to 3 MB, which is preferred. I've taken up these numbers from the Cloudera page where it has mentioned it. Now again, talking about some companies. SAS had used this for audit login, wherein you have online service which requires per user audit logs. The row scan user ID timestamp allows for efficient range scan looks to fetch per user history. Okay. Server-side filter mechanism allows efficient queries, and you can use MapReduce for analytical questions about the user behavior. So you still has got the ability to use your MapReduce. Okay. Then you will have Facebook, like what I had used earlier. Real-time counters of URL shared, links, like, impressions, 20 billion events per day, 30-second latency from click to count. Okay, tried MySQL, Cassandra, and settled down HBase. Open TSDB, like StumbleUpon I had said, where there is a scalable time series store and metrics collector, thousands of machines, each generating thousands of operational metrics, thousands of writes per second, and you have got a UI to fetch and display the graphs of metrics over time for selected host. Then this is just to show you which all companies are using it. We have discussed almost everybody: StumbleUpon, Facebook, Trend Micro. We have got Mozilla. You have got OpenLogic, Meetup. That's a kind of a site that we use internally for meetups. So that is also powered by HBase. Twitter, of course. So let's see, when should you use HBase, when should you not use HBase? Last two slides of HBase. So you need random write, random read, nor both, or both, but not either. Okay, then only you have to use HBase. You need to do many thousands of operations per second on multiple terabytes of data, like massive updates. Okay, and your access patterns are well defined. Okay, that's the time when I should go for HBase. Do not use HBase if you don't have a read or write, and you random read or write, and you basically append to the data set and tend to read the whole thing. Okay, that's how Hadoop does it. You primarily do ad hoc analytics. You don't have good access patterns, and your data sits into one big node. Okay, So then don't even touch HBase. So this was the theory part on the HBase, folks. So now what I want you to do is, can you fire up your Cloudera? You don't have to say HBase shell because, sorry, you have to say HBase shell because it's everything is find up in, is done properly in Cloudera. So can you go down to your Cloudera and say HBase shell and simply type list and see what happens, folks? So we are going to do a quick demo over here using CLI basically, and then later on we will do an extensive Java based code also. So in that time this week you will have some time to go back and look at HBase, start reading a little bit, friends, because it's one of the very crucial components. So let me also do this for you. Let me quickly go ahead. I already have my Cloudera VM up. I just need to put in my password. Okay, and I'm simply going to go ahead and say HBase and say shell. So it brings up the shell for it. And when you type this, you should see that it should get and load up the shell component for you. There it is. Okay, and I'm simply going to say list and I will press enter. And it will show you all the tables that I have. I don't have any row in this until now. So folks, I'm waiting for all of you to just type in the first two commands. Let me show it on the screen. Yep, there it is. So that you can have a look at this and let's try it out. Once you're done, just please ping back to me and let me know it's been done. Gaurav, Kaushik, Nishant, Pankaj, Sandeep, Pani, Vikas, Vivek. So Vikas is saying we move files from local file system to Hadoop where file data is distributed in HBase. So HBase is a database that can be created on Hadoop. I'm considering Hadoop as an operating system here. All data. Hey, what happened? Okay, sorry, that's fine. Hey, HBase, if it's not installed on remote servers, I'm sorry, friend. Okay, Pankaj's VMware is not working, no worries. Gaurav and, okay, no worries, no problem, Vikas. So, Kaushik has finished it, Gaurav has finished it. Because you're getting an error, what's the error that you're getting? Is it not getting into the shell? Vivek is getting an exception. On the first line or on the second line when you say list? Zookeeper connection exception, Vikas. Hey, something has not been configured properly. Okay, so like I said, it needs the basic Zookeeper reference. Although the client you're doing on a CLI, it would need that. And for Vivek also the same thing, Zookeeper connection exception. So looks like a couple of, when you do the list, yeah, you get into the shell. So by default in the configuration files it would be listed, guys. So in Cloudera I need to check how the configuration files are being kept. So for the time being you're working on a, hey Pankaj, so if you're working on a full-fledged Ubuntu, so you can look at any book, like the good book is HBase in Action. Okay, or else Definitive Guide HBase is also equally good. I would suggest to stick to Definitive Guide HBase. There they have given the complete set of things what you have to do it for on the full-fledged Ubuntu, friend. That's wonderful. So that's a very good way of trying it out. So again on this, I don't know how it's configured, friend. Okay, so what you could do is try to check it up. I will also check it up with the support team, and I will try to send you across the complete, the way you will install it on a normal stuff. So there should be in the HBase folder, and we need to know where HBase is installed. So inside that there has to be a properties. So if you can just check, guys, while I move on to the next one, both Vivek and Vikas, then you can see where the Zookeeper is loaded over there. Fine. So we saw the list and we saw how, but then it's surprising, the same thing is what is working for Sandeep, for Gaurav. It worked for me smoothly, and I think, yeah, these two, and Kaushik. So no worries, guys. So that's, we're just going to do very small hands-on, nothing more, nothing great in this, friends, okay? So we're just going to create a table, we're going to add records, and we're going to get, and we're going to say scan on it. So the first thing was starting HBase shell and listing the records. Now, we are going to, let me put this into the slideshow. So if you want to add something, first you need to create a table. Okay, so like I said, I was highly influenced by Hadoop in HBase in action. So in that, we created a table called as my table and some column family. Okay, that is a command to create a column family whose name is CF. Okay, and then remember to use single quotes. When you say list, it should show you the table that you had created, and then you can add something to HBase by saying put my table, comma, the value, and then CF colon message. Remember I said column families will have some values, so you can say CF colon message as hello HBase. So HBase stores numbers as well as strings. So in the second one, I am going to say my table as second, that is a row key. Then I'm going to say CF.foo 0 into 0. Okay, and then I say my table third, CF colon bar, and I'm going to put in some double value. Okay, so first create a table and then insert some records to it, folks. While you do this, let me actually show this so that you could actually try it, guys. Others who are there who can simply look at this demo. So I'm going to create a table, my table, comma CF. So I'm not looking at your messages, guys. Give me a minute. I'm getting into Cloudera. Okay, and I'm going to say create table, my table, comma, single quotes, column, comma, I wrote a dot by mistake, comma, single quotes, column family. Okay, pressed enter. Hey, sorry. Let me get back to the actual one. It should be only create, there is no table. Still have to do a lot of unlearning. Okay, so let me double click on this. Create, there's no table. Hey. Okay, just create my table and the column family. I have pressed enter. Okay, see, done. Now when I say list, it has shown you one table. Look at the speed at which it's coming. Okay, then I can yeah, there was for a second it said, what the crap is this?
The broadcast is now starting. All attendees are in listen-only mode.
Hello? Guys, can you hear my voice? It looks like it suddenly went away. Okay, good. For some reason, the GoToMeeting suddenly stopped. I have to start my broadcast once again. Okay, the GoToMeeting suddenly stopped. I have to start it once again, guys. Not an issue at my end. Okay, now it's on air and showing the screen. Okay, suddenly it went off and then it has come back again. Okay, good, because I hope you can hear me now. Pankaj, Pani, Kaushik, Nishant, Sandeep, yep, all of you can see it. Wonderful, guys. So I'm just continuing with the insert. So I'm going to say put my table first, CF colon message, and I'm just going to say, let me double click on this, single quotes, comma, single quotes, hello, Edgebase, press enter. Okay, now let me enter the second set of values. I'm simply going to say, oops, I'm going to say a unique key. Okay, that's done. I'm going to say my CF colon, come on. Okay, and I'm going to, spaces doesn't work, I should know that. Don't make silly mistakes. Okay, so something inside that. Okay, see, it is, I didn't define a schema. Okay, I just gave a column family. You see, it is taking virtually anything. Okay, I'll say my third, and I can specify another column, and I can put in a value here, something. See, that's also done. So this is the way how you can actually insert records into the table, folks. Wonderful. So now the next thing that we have is, once you do this, if you want to get the values out of it, you could simply say get and then specify the row key, and let's see, it gives you the column, and look at the cells and the value it will give you. So let me go back to the presentation, to the Cloudera VM, and I could simply say get, okay, I need to double click, get my table, okay, and column, comma, my primary key, that's my row key, and see how soon this came in 12 seconds. Okay, it gave you the column name, okay, it gave you the cell details, this is the timestamp, and this is what the value is. Okay, so if I, let me click back on this, if I want to put something else, CF message, and I'm going, come on, and I'm going to say hi, hello base. Okay, that's also done. Now if I say get, okay, it will tell you the timestamp when this got changed. So if you look at the timestamp, this was 304, okay, and this was 364. Okay, so it will pick up the values, and there is a way how you can get the old list using the scan. That's what you are going to see right now. Okay, so I can make changes also. See, okay. Hey Srilal, okay, the power went off for 15 minutes. So what are we showing is we are getting a demo here, Srilal. Okay. You wanted to add something to the first row. Okay. So let's get back to this. Too many windows, man, I get confused. Okay. So now we have seen the get part of it here. So now if you would want CF colon foo to the first one, column family, okay, and I'm going to say, hey, come on, okay, and I'm going to say something like this. Okay, now let's get the first. See over here, this is what you wanted, that's what I presume, Vikas, right? Yes, see, wonderful. So I have added the two different timestamps, and you see it's giving me the different columns. Only on this one row I have got this columns. Other rows can have multiple columns. This is what is called as a columnar stored frame. Okay. Now let's get down to the next one. So we have already seen the get. So reading data, just like that you pulled out your first row. The shell shows you all the cells in the row organized by column. Okay, go back and have a look at it. It is organized by the column. Okay, there we go. Okay, see, first it is organized on the row and then organized on the column. I could add something more and prove that to you, that it is organized by column. Okay, and see, there it is. You see A coming in first. This was just to show that yes, initially it was organized by row when you do a scan, and internally everything is organized by columns. Because I was saying, how does aggregate functions like min and max is faster? The reason is because since everything is stored together as a column, the time taken for you to go across multiple nodes is less than the time taken to, the time taken for you to go through multiple rows and sum it up is more, whereas in a columnar database everything is in columns, it will be faster. Okay, so you can actually test a sum of things for 100 rows in a normal SQL versus the other one. Yes, you will have to specify it across the min and max. You'll have to specify the column family and the column name also when you want to have a min and a max. Okay, if it finds something else, it will ignore that and it will go ahead with it. You have to specify a column. Exactly. Good. Now the next aspect of it, let me finish this. So the shell shows that you all the cells in the row organized by column with the values associated at each timestamp. HBase can store multiple versions of each cell. The default number of versions stored is 3, but it is configurable. At read time, only the latest value is returned unless otherwise specified. If you don't want multiple versions to be stored, we can configure it to store only one version, whereas you can't, there's no way to disable the feature of not storing the versions. Okay, so that's about the reading data part of it. Now you could also say scan, and it will give you across all the rows and across the columns and your cells. So this is the last thing that I wanted to show you as a demo in this. So let me get down to this. Let me double click on this and I will say scan and my table. Hey, no need for a I forgot the semicolon. Give me a second, folks. Scan my table. Okay, that's the right way. Yeah, it should have printed me the sorry, it has gone down. It has not gone ahead. See, look at the, for some reason something has gone wrong, so just give me a second. Suddenly I'm forgetting what is the, okay, give me a second, guys. I've got it in the other document of mine, how to come out of it, my HBase document. I'll share that also with you guys. Give me a second. Let me go to customers. Let me get down to JP Morgan. Let me get down to HBase.docx. And there is a way how you can quickly come out. I don't remember all of those things at the tip, so I just need to refer to my training sheet. Okay, we have listed, this is a Java client example. Okay, I want to get out of it. Oops, this is the full Java code, which we'll see later on. Okay. This is how it should print the whole thing. This is how I have tested and I have shown it to you. Okay, something is wrong with the command prompt over here, folks. So let me go back. Let me increase the width of this. Let me go down. Okay, Control C, and I'm going to say clear. Cool. Let me get into Hive shell again. I'm getting into the shell command once again. Okay. Hey, why Hive? Sorry. Hive, I have to say exit or quit. Yeah, exit. Clear. HBase shell. HBase shell. Hey, what's happening to my spellings? HBase shell. Come on. This is what happens if your mind works faster and your hands are not able to catch up to that speed. So I'm going to say list. Okay, I've got, see, one row. That's the table. Now I want to say scan. And I want to say my table. Come on. Single quotes. Yeah, there it is. Simple. Okay. So see the way how it comes in. For first, it has got all the values. See how it is sorted. Okay, so it is sorted on the row key value, and this is how the values would be there. Okay, we have added 3 values to the first row. Okay, that's why it's called as sparse, and second and the third, guys. So this was just a teaser example just to play with the HBase CLI. There is a full-fledged Java example. You saw a peep of that in the other document, okay, which we will be doing it next week, and after that you can do hands-on on it also. So let me go back to the questions. Yeah, exactly, that's what I did. I tried quit also. Pani says, I'm getting only one row with multiple columns. Yes, that's right. So I'm having different columns. So look at there's no schema to this. There are multiple columns, Pani. I was just reading all the messages. Okay. Yeah, that's what I did. Control C and I came back, Vikas. Row key sorted alphabetically, timestamp. So row key is sorted alphabetically, but then I don't think so there's anything in the timestamp in that. Okay, so this is more on the column. It's not on the timestamp. It's sorted alphabetically. The first sorting is on row, and the second sorting is on the column key. Clear on that, friend? Okay, thanks, Vikas. So this was a quick introduction to, or a quick overview of what is your example of HBase. The second way of using HBase is using a Java code. So next time we will use Eclipse. We will use a code to run all of these things. That's what is the plan for next week. No, today, because I would want you to focus on more of HBase. Okay, that's the reason why I'm moving it. Today we are going to start with Scoop now, because that's my objective. Because next week I would want to take this and I want to start with Zookeeper. Okay, and last week is going to be an exercise. That's my plan. Okay, so let's get back to my presentation. Let me get to the last row. So you can see here all of the data came back. Notice the order in which HBase returns the rows. They're ordered by the row name, and HBase calls it as the row key, friends. Okay, so thank you, everybody. Now let's move on to our next component. That is what is called as Scoop. In fact, this is one of the easiest and, trust me, the most commonly used component in the Hadoop ecosystem, because there are always use cases where you would want to move the structured data between your HDFS and your structured relational data stores. While you already have MapReduce, you could use this thing, what I call a DB input format, to use a MapReduce and do it, but then don't use it for the obvious reasons what we are going to do right now. Okay, so let's start with Scoop. So what is Scoop? It allows for easy import and export of data from the relational data stores. That is structured data stores. It could be a data warehouse. Okay, it could be a NoSQL data store. It could be a relational database. and it has got wonderful integration with your Hive, HBase, and Oozie, which is a workflow. So next week, if time permits, I can just give you an intro to Oozie also. So Oozie is if you want to schedule something, okay, you want to do MapReduce, you want to do Hive, you want to do Pig, and you want to schedule everything, that's what is a workflow. Okay. So Oozie is a workflow. Let me see if I can give you a quick demo on that next week, if possible. I think it should be possible, guys. Okay. So let's look at the motivation. Why do I need Scoop? So until now, we know that everybody has got structured data. So structured data is stored in databases, and enterprise data warehouse is not easily accessible for analysis in Hadoop. So the question comes to you, why do I need analysis of structured database? We already have got so many things available, right? So why do you think I have to move the data from a structured database to HDFS? Folks, a small question, if you can have your thinking cells on. So why do I need to bring my structured data from my database to my HDFS? Yep, to my distributed file system. Why? Yep, Sandeep says applications have already stored data in RDBMS. Right, so that's good, right? Why do I need it to do in what you call HDFS? Funny, parallel processing. Okay, but then I do have got my enterprise data warehouse and all that, right? So why do I move? Why should I move data? It will not. No volume. Yeah, to one extent, volume is large. Okay, that is one use case. But then see, I'll try to scale up, right? Yes, I told you that scaling up is difficult, scaling out is okay. Parallel, all that fine. Good. Sandeep has hit the bullseye. Heterogeneous data can be brought in one place. Exactly. Srilal is also correct to some extent, to integrate with big data. So see, nowadays I've got structured data, OLTP applications, but along with the customer I've got a sentiment analysis also. So I have got a user who's done a transaction. Okay, let me give you an actual example. In Progress, we had a user who had done some transactions, okay, who has purchased something. Plus, we also want to analyze, before he purchased it, did he go to our website and did he analyze? This is what I actually did with Progress, okay? Did he go down to Progress website? Was he logged in? Did he look at some pages? What all pages did he spend time more on? Remember today I said about the why did he buy this, the why rather than how aspect of it? Okay, so that is what is needed. And then what did we do? We put all of those things into HDFS itself. We even tried to correlate the support calls, you know. A single user and support calls voice also, everything has to be in one location in using your HBase. So that was an application. So do you want structured and unstructured data to be analyzed together? That's the reason why you would want to move structured data into HDFS. Why would you want to take it out? After doing MapR or after doing my Pig or Hive analysis, the answer I can quickly put it back into HDFS, into my databases. So that there are other tools like my graphical tools, my visualization tools, which don't have a connector directly to your HDFS, okay, to Hadoop. So that's the reason why I would want to use Scoop. Okay, let's carry on. You can access database and enterprise database from the Hadoop cluster. Forcing MapReduce to access data from databases is repetitive, error-prone, and non-trivial. Data preparation often comes for efficient consumption by Hadoop-based data pipelines. Okay, and current method for transferring data is inefficient or ad hoc. So for these things, I needed Scoop. Scoop is a tool to automate data transfer between structured data stores and Hadoop. The highlights of that is, it uses data stores metadata to infer structure definitions, something like Metastore. It uses MapReduce framework to transfer data in parallel. It is faster. Okay, and let me give you another example. We were talking to Microsoft. They said that for loading data into a database, because it was schema on write, it took them 6 hours. Okay, using Hadoop, it took them, trust me, flat 45 minutes because it is schema on read. So it is basically a dump operations. The validations and all of those things are not needed. He mentioned some X amount of record. I don't remember. I just remember the time. 6 hours versus 45 minutes. Okay. So that is what is the advantage. Allows structured definitions to be provisioned in Hive. Provides an extension mechanism to incorporate high performance connectors from external systems. Hey, this is another good thing. Scoop is coming up continuously with some better drivers to talk to your high performance, creating this high performance connectors. Okay, so MySQL has got a high performance connector by which your data transfer will happen. I have got a 10 million record. Okay, sorry, not 10 lakh records, and you will see how soon it can move from one to another place when you try Scoop, friends. So that's more about the enter Scoop part of it. So like I said, it's a suite of tools that connects Hadoop and your database systems. Imports tables from databases to HDFS for deep analysis. Repetitive database schema in Hive Metastore. Sorry, replicate database schema in Hive Metastore and export the MapReduce results back to the database for presentation to end users. This is what I said last time. So when you configure Scoop, okay, please remember the particular driver has to be copied to the Scoop lib folder if you're using Ubuntu like what Pankaj is using. Okay, and the beauty is there is an inbuilt Scoop driver that comes along with HD Insights, or SQL Server driver that comes along with HD Insight. That's a Microsoft product. Okay, so they were also amazed to see the way how data will go from SQL Server to your HDFS. Now, you could have done that using your MapReduce also, but then DB input, how to do that? DB input format allows database records to be used as mapper input, but then the problem with that is that connecting an entire cluster to a database is a performance nightmare. Databases have low read bandwidth than HDFS, so for deeper analysis, it's better to make a copy in HDFS first. And users must write a class that describe a record for each table. Remember the metadata? They want to import or work with the DB writable. So this is like ORM, right? Object relational mapping. You need something which will say that this column is of this particular type, right? So that's something what we have to do if we are going to use a DB input format. So why Scoop? SQL servers are already deployed opulent worldwide. Nightly processing on SQL servers has been happening for years. As Hadoop is making way into the enterprise, there was a need to move certain part of the data from your traditional RD to your Hadoop. Transferring data using scripts was okay. What you did not follow, Sandeep? If you can let me know which part you did not follow. Let's get back to the previous slide. Okay. See, you could have done MapReduce also to move data from your database to your HDFS, right? So there is an input format. Remember we said file input format. I showed you the API. There's an input format called as DB input format. Okay. So if I use DB input format, it's a performance nightmare. The databases will have low read bandwidth than HDFS. In HDFS, it is distributed, huge data is distributed. Imagine reading a 1 TB file using SQL Server or any database, and the same thing reading HDFS. It's faster. That's what I meant, read bandwidth. And typically users should write a class, because when you read something, you have to have a class which will talk about the type and the column and its data type, right? So I don't have to do any of these things in Scoop. Okay, he got it now. Wonderful, Sandeep. Let's move on. So why Scoop? Like I said, SQL servers and nightly processing has been there for ages. So as Hadoop is getting into enterprise, they wanted to move certain part of data to a traditional DB. Transferring scripts using DB is inefficient and time consuming. And right now, your traditional DB already has got report data visualization applications built in enterprise. So bringing process data from Hadoop to those applications is what is the current need of the hour. So that's why you would need Sqoop. So this is an example, okay? So you will say connect depending upon the driver, okay? By default, hey, this is something I wanted to try. I never tried it, friend. So let me say Cloudera, and let me do Control C and come out of this head. I need to double click. I need to get out of HBase. Okay, let me say clear, and let me say MySQL. Okay. Guys, this is something that I had a concern. Okay, so you need to install MySQL specifically if you want to try in Cloudera VM. If you use any other VM and if you run this, MySQL is installed by default in Ubuntu 12 onwards. So I'll show it to you. So let me close this command prompt. Let me shut down this VM. Okay, I never had this problem because I'll tell you why, friends. Let me open my window to select my VMX file. Yeah, Sandeep. So we have to install it, it looks like it, friend. Let me get into Ubuntu 12. This is my Ubuntu 12 server, and I'm powering on that machine. And when you say MySQL, it will come automatically, friend. Okay, so that's the sad part of it. We have to install it. Okay, so I'm starting with my Ubuntu. You see that. So while that happens, let me just minimize it and let me continue with the current screen, friend. So Sqoop import, the best way to install something is MySQL, okay? So you give the connector, what is the table name, username, password. You can decide the number of mappers you want and what should be the target directory. So what is import? Importing from MySQL into HDFS, okay? You always look at it from HDFS perspective. So this is how you can import from a database onto HDFS. Okay, so you can use one of my data sets and import it into HDFS. So step 1 introspects the database to gather the necessary metadata for the data being imported. Nowhere did I say what is the columns and data types and all that, right? So step 1 is what is very important that Sqoop does on its own. Step 2, a map-only Hadoop job is submitted to the cluster by Sqoop. The map-only job performs a data transfer using the metadata captured in your step 1. So that's how Sqoop would work, guys. So continuing with it, the imported data is saved into the directory and HDFS based on the table being imported. Of course, you can specify a directory where the file should be populated. By default, these files contain comma delimited fields with new lines separating different records. It's up to you. You can override the format in which data gets copied over by specifying the field separator and the record separator characters. Sqoop also supports different data formats for importing data. So users can easily import data into some Avro, that is a serialization format, by specifying -as Avro data file. And there are other options that can be used to tune the import operation. So let me go down to my VM. It should have been up and running by now. There it is. Okay, let me press enter. Hey, let me double click on this and press enter, and let me log into it. Okay, and in the command prompt, hey, Control Alt, that's how I come out of it, and I'll double click and I have to just say MySQL, and you see it has gone into the MySQL command prompt. So by default, in this 12 version onwards, your MySQL is installed. Okay, so that's fine. We have to install MySQL. That's all, guys. Okay, so this is what I wanted to prove it to you. Because Avro is a serialization engine. So if you want to serialize something, an object into some serialization format, Avro is basically used for that because it's a serialization mechanism. It doesn't use java.serialization, okay, javax.serialization. It doesn't use that Java serialization. It uses Avro if you want to serialize something. It's used in streaming API. So let me get out of this now. Let me say exit, and I can shut down my VM. let me close my VM. Okay, that's closed. That's wonderful. And let me check if this is also closed. Okay, wonderful. And let me close my workstation. Good, good. You're welcome, Vikas. So that's how import would work. Similarly, from HDFS, if you have got some processed data, you can move it back to your database. So step 1 introspects the database for metadata, followed by second step for transferring the data. Second step is for transferring the data. What it does, Scoop divides the input data sets into splits, uses individual mappers to push the splits to the database. Each map task performs this task over many transactions in order to ensure optimal throughput and minimal resource utilization. So that's the way how you will be pushing your data from your Scoop onto your, from HDFS onto your, database, whatever might be the database, guys. Okay, so that was the example, friends. So what I could do is I could actually show you the actual demo of Scoop. Okay, how am I moving the data, how am I running this. This is a part of the actual exercise what you are going to have. Okay, so let me do that. Unnecessarily I close my VM because we have time and I can actually show that demo to you. So let me go ahead. But before I go ahead, any questions on what we have seen today, folks? We saw HBase, okay? We saw the history, who are using it, the CLI part of it, the Java code of it will be discussed next time. Next time we will be talking more about Zookeeper, and I'll give about half an hour to Uzi also. So with that, we would have finished with the course, and then we will have the last session wherein we will be working on a project. Let me see if this week itself the project specs can be given to you so that we can, if you have any problem, we can discuss it next week, or in the last week, that is next week, you can show us the actual teamwork of next week, or whenever you guys are able to finish it, to show it back to me. So that's what is going to be the plan, folks. So any questions until now? A heartbeat would be appreciated so that I know I'm able to connect with everyone, friend. Good, thanks. Sandeep says he is fine till now. Others, guys? Hope you are okay with what has been covered till now. Okay, good. Thanks, Srilal. Good so far. Good, Nishant. Thanks, Kaushik. Thanks, Pani. Wonderful. So let me go ahead with the demo, and we will see the actual size and all of those aspects over there. So let me escape. Unnecessarily I close my VM, but then, okay, because it's saying the need, I think I covered the need. Can somebody tell me why do I need Scoop, guys? We just went through it because it's needed so that you can move data from a relational data store to your SDFS in a very efficient way. That's what is the need for Scoop. Did you have, Vikas, did you have something else to ask, or is this what you wanted to ask? Hey, okay, so you missed the part where you mentioned about the data type. See, because what happens is when you are doing some data movement, you will have to, how will you come to know what type is it or how is it, right? So you could use Scoop to read the data and store the structure in Hive so that the table can be created in Hive directly. So it reads the data from the data store, understands what is the metadata of it, and then does the transfer. Okay. Sandeep is saying what kind of an assignment would we get? So I think for the final project, they're looking at a live Twitter feed and using Hadoop to work on that. So let me again talk to them today and ensure that we send across these assignments to you. Sure. Thanks, Sandeep. You're welcome, Vikas. So let me minimize and let me go down to my workstation once again and boot up my Linux VM once again. Give me a second, bear with me guys. I'll say file open. For some silly reason I stopped the VM. So stupid of me, but then I didn't realize at that time I could do a demo. So power on this VM. Because I was closing everything because after the class I need to quickly take my bath and then rush to the airport. So I thought I'll close everything right now. Good. So it has logged in. Okay. You could see the boot up of the Ubuntu VM. Guys, I could have tried Cloudera also, but I'm more comfortable with my own VM. That's why I'm doing a demo. You could very well try this with your Cloudera VM also. Hey, sorry, Cloudera doesn't have MySQL, so that we need to install all that. So that's also simple, guys. You have to just untar it. It's not that difficult, friends. Okay, so let me get into it. Okay, great. So I am logging in as root with okay, cool. Now I'm going to say create database. Let's say, hey, my mistake. Come on. Okay. Create database big. Okay. Hey, big is already there. So I'll say use. Let me say create database big one. Okay. So I'm creating a database. Let me use it. So I could say use big one. Okay. Now let me create a table of cust, what I had used earlier. Create customers, and I'm going to say cust ID as varchar 7 not null. Then I'm going to use first name. I'll keep everything small. First name, which is again going to be varchar, let's say of 20, not null. Then I want last name, varchar, again 20, not null. Then I'm going to say age, int, not null. I'm going to say profession, varchar 50, not null. And last thing after that is the primary key is going to be the cust ID. Primary key is going to be the cust ID. Okay, it says customers. What does it say? You have an error. Create table. Who will write the word table? We are in not in HBase. So, okay, table created. We had one of our friends, one of the participants asking me whether he could do HBase as a part of an academic research. Okay, Nishant, you want to do your master's final year with Hadoop plus any Hadoop based technology. Why not? Please go ahead. Jump into it. So now I have got, I think I have already got, let me use WinSCP also. Control C. I think exit will work. Why Control C? Exit, good. ifconfig. Okay, I need to use my Hadoop shortcuts, WinSCP. I think I've already extracted it. All those things are already done. I just want to ensure that. Hey, what is this? No, I don't want to use that temp file. I want to log in. So 192.168. Hey, where the hell is it? .14, sorry for using a wrong word. 128. My username is not root. I put in my password. Okay, because I want to confirm that I have copied the MySQL driver. I should have. I'm just confirming that, friends. Oops, where is it? Okay, it has come. That's good. So inside my downloads, inside my lab, inside my software, inside my scoop, inside my lib, yeah, I do have the MySQL connector. I have already taken care of all that, so I can simply export some of the table, connect to that with the customers, okay, and from MySQL I can export it into HDFS. First export, then I can go to MySQL and verify. That means I've got a file. So let me tell you where the file is. If I go down to my, where am I? Okay, one more level up. Inside my data, I have got something called as cus. Okay, and if you look at the size of this is, you'll see. Yeah, I think it's 10 lakh records or something. Okay, I don't remember it offhand. I kept on changing this. I want to push this into MySQL. That's why I created a table. So let me go ahead and run this. Okay, so I'm going to say scoop, and I'm going to say export, and I'm going to connect to it. And this is my standard JDBC drivers. Hey, JDBC colon MySQL localhost / big one. Hey, sorry guys. Okay, JDBC. What's happening to my spellings today? Focus, Venkat. JDBC colon MySQL colon local / localhost big one. That's my database. Minus table. We created customers, right? Customers minus username root minus password. Oops, I'm showing you my password, guys. Okay, minus export directory from where I need to pick up the location. That is going to be, I've created a folder called as input, inside which I should have cus. Okay, let me press enter. So if everything is fine, which I think it is, it should create a MapReduce program. Okay, and when I do select the count asterisk from customers, you would see here, preparing to use streaming result set. It's beginning the code generation. Okay, the home. Okay, oops. Okay, that's fine, because I told you it will create a file, right? It has created a file called as customer, so don't worry about it. That's why. Oh my God. Okay, doesn't matter. Hard time. I didn't start my servers here, right? You remember? So that's the reason. So since it's your own thing, it doesn't work like your Cloudera VM. You have to manually start your servers. So let me do this one last time, and then I think the demo should be fine. So I need to go down to cd lab, software, Hadoop, bin. Okay, and inside that I have to say start all .sh. So you see that I'm starting my name node. Okay, I'm starting my data node. Cool. I am started with my job tracker, and I have started with my task tracker. Cool. Everything is done. Now I'll say here I need to double click on this again. MySQL. I need to type the command again. That's okay. I need to say use big one. Okay, I need, sorry, I have logged in as a user, so I'll have to say exit. Okay, I have to specifically say MySQL -u root -p, so that it will prompt me for the password, which you already know what it is. So sad, I can't use my, hey, I could have done it from, I need to do the scoop export from outside, right? So exit. I could still use the earlier ones. There it is. Scoop export. Let me run this. Good. It's setting a password. So you have to run scoop from your command prompt, right? So I anyway come out of MySQL. So now it is moving all the data. See, it's executing the command. Select t.star from customers. See here? It's executing that particular command. In fact, you should run the scoop typically from the name node. That's right. From the master. So it is running the map 0% reduce 0%. Good. That's nice. And once we are finished, once it's done, we can go back to MySQL and you could see what actually happens. Okay. What's happening to my Ubuntu? It is running. Map 0%, reduce 0%. In the meantime, I just want to see how many records do I have inside that. See, map 57%, reduce 0%. Map 75%, reduce 0%. I didn't specify the number of mappers, okay? So it has picked up the default number of mappers. Map 100%, reduce 0%. It's a map-only job. Okay, so 9,999 records. Okay, so about 10,000 records. So now if I go down to MySQL, okay, and use big one, select count asterisk from customers, and you see 999 records in my database, guys. So that's the use of scoop. Similarly, I could have exported the whole file from the database onto this also, guys. So that is it for today, guys. So my purpose was basically to show you how scoop works. The scoop document is also going to be shared with you. The Hive document is also going to be shared. So this week you have got a little bit more effort needs to be put. If I'm not mistaken, I will speak to Edureka and ensure that your exercises are also shared with you, so that you are little bit, if you can focus this week and next week, it is just finishing off whatever hard work you have done until now, folks. Okay? So that would be it. Any questions, guys? You have been very quiet today, guys. Absolutely nothing. Yep. There will be randomly groups formed for this. Randomly formed by Edureka. That's right. If I select a group, I'll be subjective. I don't want to be involved in that. Let me be very clear on what is the mode of operations what they have. So guys, if you can just bear with me, give me 2 minutes. Let me speak to Edureka right now, or else you get it via email. So I need to speak to them and get plan it up, and by end of today, a email will come down to you guys. Okay. Hope things are clear, folks. So when people don't ask questions, I typically say 2 things. Either you have followed each and every word what I said, and I really hope it's not the other one. Okay. So hope you have followed the Edgebase. It's very important ecosystem component, and Scoop is very simple. You would have seen that. Okay. And like always, the common complaint against this batch is that nobody gives a feedback. So please give a feedback, friends. I'll appreciate that. Just 2 more weeks. Okay. So just 1 more week, in fact, technically. The other week will be for the project. So after that, you guys are going to be free. So that's it from my side, guys. Tata, bye-bye. And any questions? I'm not hearing absolutely anything from anybody. Yeah, Vikas, you would need to play with Edgebase. Yeah, sure. If you need any help, if it's not done, then I can help you, Vikas. Thanks, Nishant. Lovely. Thanks, Vikas. Thank you, mate. So, yep, please work on the exercises of 3 things. Thanks, Srilal. Thanks, Kaushik. And try to finish it off. Thank you, Pani. Yeah, Vivek, a lot of catching up to do, I know that. So, thanks, Vivek. So, thanks everybody, guys. And this is Venkat signing off. Next Sunday, same time, we will continue on with Edgebase, and we will do Zookeeper and Oozy. That will be our last session, friends. Thanks everybody. Bye Pankaj. Bye Kaushik. See you Sandeep. Thanks Sandeep. Wonderful. Yep, next base of Java example. Bye Gaurav. Exactly. Thank you Gaurav. Wonderful. So thanks everybody, and see you later on. Bye bye for now.